Okay, we're given a function f in two variables, x and y. X squared times the square root of y. We're asked to calculate f of 2, 4. So that simply means f of 2, 4 is when you replace the x in the original function with a 2 and the y in the original function with a 4. Do a little bit of simplifying down that we have 2 squared is 4 and the square root of 4 is 2, so 4 times 2 works out to be 8. All right, next what we're going to do is go ahead and in order to evaluate the partial derivative with respect to x at 2, 4, we're going to have to find the partial derivative first with respect to x. So remember, when you're doing this, you're treating x as though it's your only variable, and any of the y's or any other letter would be treated as constants. So in our case, we can say the derivative of x squared using the power rule is 2x to the first power, and then we're going to still multiply that by the square root of y. Now we can evaluate that now that we've taken the partial derivative with respect to x at 2, 4. So that means we're going to replace the x with a 2 and the y with a 4. Well, this works out to be 2 times 2 makes 4, multiplied by the square root of 4 is 2. 4 times 2 also happens to work out to be 8. Next, the partial derivative with respect to y. In this case, we're going to treat the x as a constant and the y as our only variable. To take this partial derivative, though, I'm going to go ahead and think of the y underneath the square root as the same thing as y to the 1/2 power. That way I can go ahead and use the power rule to take this partial derivative. So the x squared is going to come along, treat it as a constant. We're going to bring the exponent down in front, reduce the exponent by 1, so 1/2 minus 1 makes negative 1/2, and then try to evaluate this at 2, 4. But before I evaluate it at 2, 4, I'm going to just clean this up a little bit. All right, the x squared can be in the numerator. We have a 2 in the denominator. I'm also going to move that y to the 1/2 power down to the denominator and make it a positive exponent. The very last thing I'm going to go ahead and do is, instead of a square root, or instead of a 1/2 power, I'm going to replace that with a square root because I visualize it a little bit better that way. All right, so let's evaluate this at 2, 4. So that'll be 2 replacing the x in the numerator, and then we have 2 times the square root of 4 in the denominator, so it'll work out to be 4 over 2 times 2, or 4 over 4 works out to be 1. All right, next let's go ahead and create a formula for getting this estimate. So in the formula you can see it's laid out with f of a, b. In this case, a is going to be 2, our x value, and b is going to be 4, our y value. All right, so we can estimate this by filling in one at a time here. F of 2, 4 was 8 from the top, plus the partial derivative evaluated at 2, 4. Partial derivative with respect to x evaluated at 2, 4 worked out to be 8. This next value, so the first value we filled in, the next value, and then it goes as x minus our value for a, which we said was 2, plus the partial derivative with respect to y evaluated at 2, 4 was 1, multiplied by y minus our value for b was our y value of 4. The last thing we need to do here is we need to get this estimation of f of 1.9 comma 4.1. So that's going to be 8 plus 8 times 1.9 is going to get filled in for the x, minus 2, plus 1 times y gets filled in with 4.1 minus 4. So our estimation can be 8, just reducing down a little bit as we go here. And then inside the parentheses, 1.9 minus 2 makes negative 1/10, negative 0.1, plus 1 times 4.1 minus 4 is positive 1/10. So that'll be 8 minus 8/10 plus 1/10. And as we combine all of this together, pretty sure we get 7.3 as our final estimation. So I hope this helps out as you're working on using partial derivatives to estimate values at points. Good luck.